And we got 10.1, use properties of tangents. Tangents being something like this. Whee! Note that this is perpendicular to the radius, even though I drew it pretty poorly. Go ahead and draw what you see here and here. You can draw that on the same circle if you like. It's just identifying parts of a circle. Diameter you know, or hope you know. Radius is there. The center's in the middle of it. A chord, on the other hand, goes through it. Just like on an acoustic guitar, you have strings going through and you think of those as the chord. But the chord in our case is something that connects to the circumference of the circle, here and here. A secant, on the other hand, secant means cut through. It's the entire line that contains part of the chord. Point of tangency is the point where a tangent line crosses the circle. A tangent line only crosses the circle at one point. Note that it is perpendicular to the radius, or the diameter. So you should be able to take something like this and identify the parts that you need. In fact, I'm not even going to do this because I think it's so simple. Well, it looks like I can't show it. So go ahead and see if you can get this. Check your answer in the book. Pretty simple stuff. Same thing. All right. Use a diagram to find the given lengths. We have these circles on a coordinate plane, so we can find our radius and our diameter. 3 is the radius of circle A, 6 is the diameter, and so forth. Circle B, 2 radius, 4 diameter. Oh my gosh, this is so easy. Do we really have to do it? Later on, though, it does get a little confusing. So let's just identify coplanar circles, circles in the same plane. Note that there could be 2 points of intersection with a picture like this and this. We have 1 point where the circle, little one's on the inside or it's on the outside. And then we have concentric, con meaning width and centric meaning center, where there's no points of intersection. You can also have what's called common tangents. Notice tangent lines just cross the circle at one given point. These are common tangents, 2 circles that share the same tangent line. Go ahead and draw these in your notes as well. So see how many different common tangents you can draw? Go ahead and pause the video and see if you get the same thing as me. Or the textbook. Ha! There's the first one. There's the second one. And there's the third. Is that what you got? Ha! We'll do some of those maybe. Tangent, perpendicular, been saying that this whole time. It's key. We can set up some right triangles with that, in fact. Oh, look at that. We got a right triangle. It says in the diagram, PT is the radius of circle P. Is ST tangent? Well, if it is tangent, then this has to satisfy the Pythagorean theorem. So that means I have to take 12 squared. And to be honest with you, 37 is not really clear here to me if this is the total distance or if it's just this piece. But seeing as it's in the middle of the segment, I'm going to assume it's the hypotenuse or the total length. So let's see if it is congruent. In fact, this is starting to look a little familiar, but I'm supposing you guys don't remember your triples. So let's go ahead and evaluate these. 12 squared plus 35 squared, that is equal to 1369. Sounds like the Black Plague. And 1369. Yes, it is a triple, just like I was assuming. Since this satisfies, these 3 segments satisfy the Pythagorean theorem, this is a right triangle. And if it's a right triangle, this angle is a right angle. And if it's a right angle, then this is a tangent. Wow, that's a lot of if-thens. Something like this, though, is when you've got the short segment, 50, and you've got R and R. We can use that to in a right triangle because it says this is a point of tangency. So we have 80 squared plus R squared equal to 50 plus R, and it's grouped because it's a total segment. And if you note, this is Algebra 1 quadratics, also used in Algebra 2. So 80 squared is 6,400. We still have the R squared. I'm just going to FOIL this. If you remember foiling 50 plus R times 50 plus R. And we got, that's an R, and that's an R. First, outer, inner, last. 50 times 50 is 25 with 2 extra zeros. Plus 50R plus 50R is 100R. And R times R is R squared. Notice we have an R squared on both sides, so if we subtract them, boom, they go away. Now we just have a simple linear equation where we can take 6,400 and we can subtract 2,500, and we get 3,900. And it's equal to 100R. If you divide out the 100s, then you get R is equal to 39. It's asking you to find the radius, so we're done, and we just need to write our units. Whew, that was fast. Let's go to another example. This is something that we might prove in class, but it's pretty much saying that if there is some point outside of the figure and there are some tangent lines, then those two segments must be congruent. It has to do with triangles, and this is a right triangle, this is a right triangle, this is congruent to itself, and this is the radius, and this is the radius. So by hypotenuse leg of these two triangles, those two triangles are congruent, which means their corresponding parts of congruent triangles are congruent, which means that TS is congruent to RS. I said I wasn't going to prove it, and then I did. I guess I got excited. All right, so that means that 28 is equal to 3x plus 4. Algebra comes out of nowhere. So we just subtract 4 from both sides, and we get 24 is equal to 3x, and divide by 3. X is equal to 8. Find the value of x. I did that so I can be done. By the way, if I'm moving too fast, just rewind it. Same situation, guided practice, pretty much the same stuff that we're doing. Note that in this case, you would square root both sides, but you do not do the plus or minus. Not in geometry. We'll only allow positive distances. All right, that's pretty much it for the video. We'll go through some practice next class.